Hello everyone. In this video, I'm taking a brief discussion about advanced databases. So advanced databases in which we have a first one active database. As the name itself, it is giving the identity active database. Active means that on-spot action it will be taking here. Immediate action it will be taking. It is suitable for the real-time data processing. So it will be using the triggers. These are nothing but stored procedures, or we may say these are the database objects and are automatically executed or fired when a specified event occurs on a particular table. So already one of the table, it is created, data it is stored in the database. For that, if we need to take some immediate actions, that will be done by implementing the triggers here. In which of the database we are using the triggers, those are called as active databases. Then first of all, before diving into these databases, we will have a clear idea about the triggers. So here we have a trigger. The create trigger, the syntax of creating the trigger, it will comes like this. First line, it will be creating the trigger with a particular name in which it is invoked for that action. And here we have a before and after. Here, three types of the events we can notice, that is the insert, update, and delete. These are the three events we are performing on the particular table to which we are writing the trigger. And these events, whether these events that trigger it is required to execute before these events or after the events, that it will be given here. Before means before taking the event, the trigger execution, it will be starting. And after means after by performing the event, it may be the inserting record, or it may be updating the record or deleting the record. After that event, it will be performing the trigger operation. Then for each row wise, it will be applying here. And here we have this is a event. Based on this event, here we have a condition as well as action. So within the body, we are giving the condition. If the condition is true, then only the action of that trigger, it will be taken on the table here. This is the syntax of the trigger. Very simple it is. Name of the trigger, in which what is the action it is stored for that particular table, it will be stored here. And here we have a before and after, when the trigger is required to take the action, whether it is before the event or after the event. And then here we have a begin condition as well as that related action. That's what trigger it will be activated in terms of the event, condition as well as action. It will be working in this series. So just we can notice the syntax here. First of all, here we have an event, whether it is a read, write, or update, read, update, or delete, any of the event it is, and before or after the event that it will be given. And after that, here within the body we have a condition. If the condition is true, then it will goes to the action one. If the condition is false, then it will go for another action. Like this, here we have a one real life example also it is given. Active databases, they will be having a certain features. As it is an advanced database, it is having some advanced features here. First of all, it is a event driven. Means based on the event, it will be performing the operation. Then next here we have a rule based, that we are giving the certain conditions, rules and regulations. Based on those rules, it will be working here, if else and all. Then real time, it is performing the real time operation. Means on spot operation, it will be performing here, active operation. Then next here we have a trigger based. Active database, it is a trigger based. Trigger is nothing but a automatic action taken event here. At action taken object. Also, we may say it is a stored procedure. Stored procedure, it is a small program that it is required to call. After by calling the function, it will be performing. But here in trigger, no need to call the function and all. Automatically, it will be activated based on the event. The next here we have a automated. It is a automatic and scalable. That once the database it is stored, that data of the database, it will be flexible. We can expand and we can shrink as per the requirement. We can go for the modification. Supports multiple data resources. That this database, it will be supporting the different type of the data. It may be the text, audio, video, different type of data and all it will be maintaining here. So it is the advanced one. This is about the active database. Next one, we have a temporal database. One more special database it will come, temporal. The main identity of the temporal database is the time-based. It will be storing the information, organization of information based on the timing it will be taking here. Time-based information it will be storing. Means each and every information with respect to the time when it is occurred. That's what time series will be divided into three types here. One is a valid time, another is a transaction time, and one more we have a decision time. So here we have some actual real life events, real life activities, the real life facts we are collecting here. So when the fact it is occurred in the real life, that it will be of the valid time. And when that real life fact it is entered in the database, that it is the transactional transaction time here. And third one, we have a decision time is a temporal database in the time at which the decision is made about the fact. Now here the fact it has been taken in reality and it is stored in the database. And based on that stored data, whatever decision it will be taking, that it will comes under the decision time here. So like this, here we have a three timings we can notice in temporal database. Temporal database data is organized based on the timing, time-based information it will take in the organization. So each and every fact data it will be storing with respect to three timings, valid, transaction, as well as decision here. Then applications of temporal database, as it is a time-based finance, wherever there is a time critic it is required, such type of the applications we can notice here. The finance as well as healthcare and banking, that everywhere the time implementation it is very crucial. So here one of the example you can notice that suppose employee table consists of a department table. Here we have an employee table consists of a department table that the employee is assigned to. So one of the employees working on the particular department, from that department, he transferred to another department at some point in the time. This can be tracked in the employee table. Is an uh, application time period table that assigns the appropriate time period to each department. Means here the employee will be working in the different department previously, and after by transferring, he'll be having the different department. So both the department with respect to the timing, each of the action, whatever it has been taken, that it will be stored in the employee table. This is how the temporal database will be working here. And then next comes temporal relation here. So in temporal database, relation between the facts will be existed in the types of temporal relations. That one is a unitemporal relation, and one more we have a bitemporal, and one more tritemporal. So unitemporal, that it will be having only the valid or transaction time. Any one of these two, valid or transaction, that is a real fact. Otherwise, when it is stored in the database. Then bitemporal relation, it will be having both, that is valid as well as transaction time. Not any one, both it will be having here. And tritemporal relation, the relation which is associated with the three aspects, namely valid time, transaction time, as well as decision time. It will be having the three time quantums here. That is a valid, transaction, as well as decision. That's what it is called as a tritemporal relation. This is about the temporal database. And then next special database is the special database itself. Here we have it is a database that is optimized for storing, querying data that represents an object defined in a geometrical figure, that is a geometric shape. So here we can notice the data may be stored in terms of the point type, line type, otherwise it is in the polygon type. So here we have that geometric objects, main that objects will be configured and figured by using the points, lines, as well as polygons here. In order to store these, that we need special database here. Means not only the numerical data, some of the assumption that qualitative as well as quantitative data we need to store, that it is possible in case of the special database. So in special database, information it will be stored in two types. The data types, major two types of the data we can notice here, computer aided design, and one more we have a geographic data. So CAD data as well as geographic data means whatever the data is stored in this database, it will be categorized into main two types here. One is a computer aided design. And this CAD data, usually it will be stored in terms of the line as well as polygons. And then here we have a one more geographic data. It will be having the vector as well as raster data. Raster data means it will be storing the data pixel wise, that is a point wise information in order to give the realistic identity of the object. Maybe it is a geographical area, that it may be the density of the particular thing, or it any of the real world object. We need to show that it will comes under the raster data. Vector data means the data which can be formed by using the lines here. Means series of points to form the line it is. By using line, whatever data it is stored, line format data, that it will comes under the vector. And pixel format data, it will be coming under the raster here. So these two types we are getting under the geographic data. Especially it is used to measure the different geographical areas and all. So here we have a three types of special queries, what we are writing for this database. First one, it is a special range queries. If it is required to find all the cities within 50 kilometer of the Salem. And nearest neighbor queries. Find 10 nearest cities to Salem. And special join queries. Here we have a multiple queries with the join operation it will be given here. That is complex query it will be given. Like this, here we have a different types of the complexity queries we can apply for the database in order to calculate the geographical area, and it may be of the density of the rain, and it may be of a quantity of some objects, that it will be taken under the special database. So applications of the special database: GIS, that is Geographic Information System; map, if we need to specify the map of the certain areas and all, that it will be in the realistic. It is not by using the lines and all. It will comes under the raster method. And one more we have a MMIS, that is a multimedia information system. Multimedia means more than one type of the medias here, that is audio, video, etc. It will comes here. And CAD, computer aided design, surface of the design object and all. If we need to design, that we need to plan for the different parts of the vehicle and all, that designing it will comes under the CAD. So this it will be taken with the vector type of the data. So this one it is suitable for the raster data, and this one it is for the vector. And here it will be both mixed. Then next we have a multimedia database. Multimedia, the name itself, it is giving the identity. What is the definition of the multimedia? Same, it is applicable for the database also. Here we have a multimedia is nothing but a audio, video, text, images, animation, everything it will comes. So in order to store the data related to all these multimedia aspects, which of the database it is convenient, that is called as a multimedia database. So here we have the software which it will be maintaining. It is a very complex software because it is required to maintain all, it is required to store all this type of the different data types, the data, as well as communication, as well as querying. That complex query and all, it will be managed with some of the software, that is the framework, that it is called as a multimedia database management system, that it will be controlling, it will be storing the data, and it will be controlling the data with the certain operations along with the security, that it is called as a database management system here. Then here we have a content of multimedia database, that media data, actual data representing an object, it is means the fact what it is stored, whether it is audio, video, anything. That is media. Next one, it is a media format data. That media format data means that what type of the data and how it is required to store and what is the quality of that data with respect to the sampling rate, resolution, encoding scheme, etc. It will be stored along with the data. That is the metadata, data upon data it will be stored here. Then media keyword data, that is keywords description related to the generation of data. It is also known as a content descriptive data. That is the description of the data it is. Like a meta, it is also one type of the metadata, data upon data it will be stored here. Not only the data, along with the data when it is stored, the date, time and place of recording, everything it will be stored here. Then media feature data, that is content dependent data such as a distribution of colors and all. Again, the appearance of the object, how it is, that related information also it is stored here. So here we have a different content in the database. Means in multimedia database, it will be having the data in terms of all these bifurcations. Then next we have a types of multimedia applications. First one, we have a repository application where it will be repository is nothing but a stored. That data it is stored for the satellite images, engineering drawings, and radiology, scan pictures, etc. And one more, we have a presentation applications, real-time editing analysis, and one more collaborative work using multimedia information, teamwork and all, the intelligent healthcare networks and all it will comes. So multi-dimensional data model, it is very, very important here. Next one, it is a multi-dimensional data model. Multi-dimension means usually data will be stored in 2 dimension, that is the height and width, tabular format. Only it will be having the 2 dimension. But in reality, the real object, it will be having the 3 dimension. So that more than 2 dimension, wherever it will be noticed, that is called as a multi-dimension here. So here we have a multi-dimensional data model. It is used to store multiple tables, multiple data at a time, and it will be comparing and contrasting, and it will take the analysis of these different data. So here we have a multiple dimensions. For the analysis, it is very convenient in case of the multidimensional. Main objective of the multidimensional data model is to analyze the data to get different decision, the valuable decision based on the proper analysis of the complex data here. So mainly it is used in the OLAP, that is the online analytical processing. The data warehousing uses multidimensional database. Main application, it will comes under the data warehouse. It represents data in the term of data cubes. So here usually we have a table format, but when it is more than 2 dimension, that we need to specify the multiple data in terms of the cubes, data cubes. And it is defined by dimensions and facts. So here we have a dimensions and facts are the major consideration when we are taking the analysis of the data here. So in this we have a dimensions. It will be giving numerical measures. Facts are the numerical measures and fact tables containing the measures of table related measures of the related dimensional tables or names of the facts here. So here we have this is how we are representing the multidimensional data here. So it will be stored in terms of the cube. In each and every dimension, we can show with the separate table content here. So in this example, we have taken product time as well as location. 3 dimension it is taken here. 3 different tables are taken for the analysis with their attributes. So comparison and contrast with respect to this, it will be taking Q format. And then here we have a same thing we need to represent in the tabular format, but basically in database, it will be stored like this. And this is a conceptual appearance of this data for the analysis. So here it will be storing the location, 3 different locations, Delhi, Kolkata, as well as Mumbai. And then here we have items. In each of the city, we have three different items it is taken. And here we have a time quantum, it will be taken. So multiple data, it will be compared with the multiple tables, multiple tabular columns here. This is how it will be storing the multidimensional data. So multidimensional data model, it will be having certain steps in order to collect and store the information. First of all, here we have assembling the data from the client here and grouping different segments of the systems and noticing the different proportions and preparing the actual time factors and their respective qualities, and then finding the actuality of factors which are listed previously and their qualities. And then finally, we have a building the schema to place the data with respect to the information collected from the steps above. So first step, collecting the information it is, and then grouping. By seeing the nature of those information, they will be grouped into the different categories, and then noticing the different proportions. So which of the category it will be having the higher requirement and all that inquiries and all analysis, which is having the prominency and all that, it will be categorized here, and preparing the actual time factors and their respective qualities. Once again, here we have a actual time factors, which are the factors are required for the actual queries and all that, it will be categorized here, and finding the actuality of the factors which are listed previously. So the comparison and contrast of those collected and stored information, and then building the schema. Finally, it will go for the schema building here. That is a representation. Here, the picturization of the data, how it is stored. Then next here we have a features of multidimensional data model, measures, dimensions, cubes, aggregation. So measures means attributes for which we are applying different types of the numerical computations, that analysis and measurements it will be applied. Then dimensions. Here we have a dimension. It is how many tables we are taking for the analysis. 2 dimension, 3 dimension, that it will be given here. And cubes. What is the conceptual representation of those multiple dimensions? That it will be shown in the cubes here. Aggregation. It is a process of summarizing data. That aggregation functions like finding average, sum, as well as maximum, minimum, that it will be performed on the measurable data in order to take the proper analysis. Then next one, we have a drill down and roll up. Drill down means suppose now we have a multiple columns that we need to reduce for the simplicity. And roll up means if we need to expand those simplified. Suppose now here we have a 10 different data, some of all those it is taken to drill down to the 10 to 1 single row it will be taking. And that only again, if it is required to expand, the sum it will be distributed with respect to the different items, then it will be of the roll up. And like that only hierarchies and OLAP, that is the online analytical processing. These are the different features of the multi-dimensions. And then here we have a deductive database. Next one comes deductive database. So deductive database, it will be using the logic-based rules. It is a type of database system that extends relational database. Relational database itself, it is extended with some logic-based rules for the mechanism of defining as well as querying the data. In order to define and query the complex queries and all, here we are using some logic-based rules. Means database, not only the relational data it will be having here, along with the tabular information, it is having certain logic-based rules. According to those rules, the execution of the queries it will be taking here. That everything it will be stored in the database itself. So here we have a deductive reasoning. Deductive means actually here what happens, we have a some specific, general to specific it will be coming. Suppose now we have some generalized data it is collected. From that we are coming for the specific conclusion, then it will be called as a deductive reasoning. And one more we are having here, inductive. That is opposite to that of the deductive it will comes. Now here we have to focus on the deductive itself, and the data, relational data as well as logic based rules. They will be stored in a language like data log, which is based on the Prolog. Actually, Prolog, it is a programming logic. One of the language belongs to the artificial intelligence. So how data it is stored and it will be performing the operation that we can notice here. Here we have a key concepts of deductive databases. One is the facts, another is the rules, and one more we have a queries. So first here we have a fact. Facts also called as a extensional database here. In this, the data it will be stored in this format along with the relational data. Here we have a facts will be storing like this by using the Prolog, employee, John, manager, employee, Tushan, engineer. Means here we have a employee table. In employee table, we have a two persons with a two different designation. It has been stored. Then upon this fact, there is a rule. What is the rule it is implemented means senior employee X. Who is a senior employee? Senior employee is nothing but a who is having the designation manager. That's what here it will be given. This also it is stored as a rule in the database. Rule what it will say that employee who is having the designation manager, he is a senior employee. That X means the name of the person. Now here in this database, John is having the manager, the designation manager. That's what John manager. So senior manager is nothing, nobody, John here. And this is the rule. It is stored like this. Then next we have a query. The query how it is performing means senior employee John. Now it will be retrieving the result by comparing this rule that now it will be retrieving John here. If it is true, then it will be this query will return true because John is the manager. If it is a false, when it is comparing, suppose instead of John it is taken Sushan, it will be false here. Like this here, the database itself, it will be storing the information that is in one term of the logics, that is the facts, rules, as well as queries with respect to each and every data, whatever it will be stored here. So facts, it will be showing how the data it is stored in context, and rules that for the stored data context, it will be deriving some rules here. Based on the rules, it will be retrieving the result, whether it will be finding whether the result is true or false. This is how it will be stored the information in deductive database. The architecture, it will be shown like that. Here we have a database plus inference, and then we have a deductive database. Here in this, we have a database, it is stored the data. Based on that, we have some inference rules it will be having. And when both together are executed, then we have a deductive database conclusion it will be giving. With respect to this diagram, here we have a identity, it is coming like this. Now here it is a facts, and here it is a rule, that database, inference, and then for that we have a conclusion, that result, whether it is a true or false. This is how data it is stored in the deductive database. So features of the deductive database: declarative querying, recursion, inference mechanism. So here we have a inference mechanism. In this we have a forward chaining as well as backward chaining. So forward chaining means it will start from the data, that is generalized information, and come to the conclusion. And backward chaining means it will start from the conclusion and it will comes to the generalized data. Means here it is a general to specific, that is forward chaining. Backward chaining, specific to general, it will comes, that top down as well as bottom up approach. So which is very useful in artificial intelligence, that is a neural networks, deep learning and all, they will be using all these rules. So there, this database, it is very much applicable. So applications of the deductive database: artificial intelligence and natural language processing. And then expert systems, semantic web, that is reasoning over linked data and all, meaningful information it will be retrieving. Then next we have a data integration used to combine information from different sources.